Welcome to College Algebra, Module 4, Topic 4.1. This is linear equations. The first objective is equations in one variable. An equation is a statement that two mathematical expressions are equal. An equation must contain an equal sign. Most equations can be solved. An equation in one variable is an equation that involves only one variable in the expressions. Some equations have no variable, some have one variable, and some may have more than one. Some examples of equations are 4 plus 9 equals 13. That is an equation with no variables. X plus 9 equals 13 is an equation with one variable. 2x minus 5 equals 4x plus 3. Notice the left side is an expression and the right side is an expression. X plus 3 over 2 equals 5 minus x over 4. That is also an equation. This last one is an equation, although it has two variables, x and y. A solution of an equation is a value that gives a true statement when substituted for the variable. The set of all solutions is called the solution set. Some equations have one solution. Some may have more than one solution, and some equations do not have a solution. If two equations have exactly the same solution set, then they are called equivalent equations, and they are said to be equivalent. We're going to use this fact when we start solving equations. For instance, we may have an equation 2x plus 3 equals 5. Just looking at that, we may not know what the solution is. This equation is equivalent to the equation 2x is equal to 2. This equation is also equivalent to the equation x equals 1. Well, looking at it, we can look at the third equation and know that the solution is 1. Does that work in the others? Well, 2 times 1 is 2. 1 is also a solution there. And then if we plugged it in the first one, 2 times 1 is 2, 2 plus 3 is 5, 1 is also a solution to the first one. Therefore, these three equations are equivalent, although the third one was easiest to eyeball and know what the solution was. A linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers and a does not equal 0. Since a can't be 0, that means we must have an ax term in our equation. That can be 2x, negative 5x, or 1/2 x, but there has to be at least one x term. In order to be a linear equation in one variable, there can only be one variable and it must be to the first power. Find the solution of each equation. Well, the equation x plus 2 equals 3, that means what number plus 2 equals 3? We know the solution is 1. Now when we look at an equation like that, x plus 2 equals x plus 3, think about it. There's not a number that we can put in here that when we add 2, that we can also at the same time put the number in and add 3 and get the same answer on both sides. This equation will not have a solution. So anytime you run into this situation, we call this a contradiction, or sometimes we will just say there is no solution. On the other hand, if you look at this equation, you know that by doing distributive property, 3 times x is 3x, 3 times 2 is 6, so we know that the left-hand side is exactly the same thing as the right-hand side. In this case, any value of x will make this true. This is what we call an identity. And sometimes what we will do is we will just write down many solutions. Now we need to determine whether the equation is linear or nonlinear. Remember, a linear equation looks like a plus b. Now we want to determine whether the equation is linear or nonlinear. Remember, a linear equation looks like ax plus b equals 0. So for this equation, you notice we've got an x squared? Well, that makes it not linear because linear, the highest power can only be 1. 5x plus 2 equals 4 times x minus 7. Notice you only have x. If you look at this side and do distributive property, 4 times x is 4x, 4 times 7 is 28. We could rearrange the terms in this equation and get only one x term and only one number term. Therefore, this is a linear equation. Now this one's a little bit tricky. X plus 3 over 2 equals 5 minus x over 4. If we want to see if we've got just an x term, we can multiply both sides by the least common denominator, which is 8. We're going to learn this in the next section. The next equation, x plus 3 over 2 equals 5 minus x over 4. If we're just trying to find out if it's linear or nonlinear, we can look. We know we've only got an x on both sides, and the x is to the first power. Therefore, that one will be a linear equation. This one, you notice we've got an x on both sides, but do you see how this one has an x in the denominator? That means it's not going to be a linear equation, because to be linear it has to have one variable, and that variable has to be to the first power. And this one, we've got an x on both sides, but notice this x is underneath the square root sign. Therefore, that one will also be nonlinear. Objective 2 is solving a linear equation. We solve a linear equation by getting equivalent equations until the solution becomes obvious. Our goal is to get the variable on one side of the equation by itself. The number on the other side of the equation is the solution. Remember earlier we went 2x plus 3 equals 5. We ended up with x equals 1. This is our goal. We want to get x equals a number, and that number is the solution. Things you can do when solving a linear equation. You can add the same value to both sides of an equation without changing the solution. This is what we call the addition property of equality. You can also subtract the same value from both sides of an equation without changing the solution. You can multiply both sides of an equation by a non-zero number without changing the solution. You just can't use 0, because then your equation becomes 0 equals 0, which has no solution. Also, you can divide both sides of an equation by a non-zero number without changing the solution. Remember, you just can't divide anything by 0. Okay, here are some steps for solving linear equations. The first step is to get rid of parentheses if possible. This is probably where you're going to use your distributive property. Next thing you want to do is get rid of fractions if you have them. Now there's a little trick for that says if you multiply both sides by the LCD, next you want to get rid of fractions if necessary. To do this, there's a little trick that helps, and what it says is if you multiply both sides of the equation by the LCD, then your fractions will disappear. That makes it a lot easier to solve these equations. Third thing is simplify each side by combining like terms. Then you want to get all variable terms to one side of the equation. Once you do that, get all of the number terms to the other side of the equation. And then finally you want to get just the variable on the side by itself. Last step, always check, which means take your solution, plug it back into the original problem. If you get the same number on both sides, then your solution is correct. As a note, you probably will not need all steps in every problem, but here they are just in case. Okay, let's do some examples. Solve, and then identify as conditional, which means there has a solution, contradiction, which means there is no solution, or an identity, which means there's many solutions. 4x minus 8 equals 0. Well, there's no parentheses, no fractions. We've already got all of the x terms on one side of the equation. So now we want to get the number terms to the other side. Because this says subtract 8, we're going to do the opposite and add 8. This is where we use the fact that you can add the same number to both sides of an equation without changing the solution. Left side, minus 8 plus 8 cancels out to give us 0, so the left side is just 4x. The right side, 0 plus 8 equals 8. Once you get letters on one side, numbers on the other, now you want to get just x on a side by itself. So because x is being multiplied by 4, we're going to do the opposite and divide both sides by 4. When we do that, we get x is equal to 2. This is our solution. To check it, go back to the original problem, plug x in, or plug 2 in for x, so we get 4 times 2 is 8. 8 minus 8 is 0, so that checks out. Let's do another one. This time we've got parentheses, so the first thing we're going to do is apply the distributive property. So multiply everything in the parentheses by 5. We get 5x minus 10 equals negative 7. There's nothing to simplify on either side, so we get x's on one side. Well, all of the x's are already on one side. We need the numbers to the other, so we're going to go plus 10 plus 10. So we get 5x is equal to 3. Then we're going to go through and get just x on a side by itself. So we're going to divide by 5. Remember, if you're multiplying by 5, then you divide by 5, which gives us x is equal to 3 over 5. Or if you want to put it in your calculator, you would get 0.6. To check it, you would plug it back into the original problem and make sure you get the same answer on both sides. Here's the check step to show if you plug in 3/5, you do end up with the same number on both sides. Before we go on to the next slide, let me back up. X equals 2, because there was a solution, we would say that this was a conditional equation, meaning it's true under the condition that x equals 2. Same thing for the second equation. Because we found a solution, this would be conditional because it's true under the condition that x is equal to 3 over 5. Okay, next example. Now this one does not have parentheses, but we're going to get all the letter terms or the variables on one side. So we've got a positive 2t here, so we're going to subtract 2t from both sides of the equation. That would give us 3t minus 6 equals 3. Then we're going to add the number terms back to the other side. So this was a minus 6, so we are going to do plus 6 on both sides of the equal sign, which gives us 3t equals 9. Divide by 3, so we get t is equal to 3. Again, conditional equation because we were able to find a solution. Now this one has parentheses on both sides, but we're going to do exactly the same thing. Distribute the 5 on this side, so we get 5a minus 10. Then on this side we're going to distribute the negative 2, so we'd get negative 2 minus negative 2a, or remember you could look at this and say negative 2 times a negative a, which is plus a positive 2a. We need to get the variables on one side, so we'll subtract 2a from both sides. Then we bring the numbers to the other side, which would give us 3a is equal to 8. Divide both sides by 3, and we would get 8 over 3. Again, conditional equation because there was a solution. Next equation. To get rid of the parentheses, we're going to distribute the 2. So we get 2x plus 6 equals 2x minus 2. To get all of the variable terms on one side, we're going to subtract 2x from both sides. So we get 6 equals negative 2. You see how all the variable terms canceled? That means it's one of these special cases. Because 6 does not equal negative 2, that means it does not matter what the value of x was, these two sides are never going to be equal Therefore, there is no solution. Remember, we call this a contradiction. Now, this is one where we're going to use the trick. There's no parentheses, so next we want to eliminate the fractions. Notice that the least common denominator for this problem is 12. So we're going to multiply both sides of the equation by 12. Well, when we do that, the first term becomes 12 times x over 4. The second term becomes 12 times 5. And then the third term becomes 12 times 1/3. Well, to multiply 12 times x over 4, we can do our cross cancel. 4 goes into 4 once, 4 goes into 12 3 times. 3 times x is 3x. Second term, there was no fraction, so we just get 12 times 5 is 60. And then the third term, we could cancel the 3 and the 12, which would give us 4. Now we want to go back and get the variables on one side, the numbers on the other. So we are going to subtract 60 from both sides. So we get 3x equals negative 56. To solve that, divide both sides by 3, and we get x equals negative 56 over 3. Now, if you guys are like me, I don't care much about plugging in negative 56 over 3 to check this. So this might be a good time to use our calculator. Okay, to check this, we can just go ahead and plug in negative 56 thirds for x. So in that first fraction, we would get negative 56 divided by 3. Close that to include the fraction, divided by 4. I'm going to go ahead and hit enter to get that answer. Plus the 5. So our left-hand side of the equation has a value of 0.333 repeating. The right side is just the fraction 1/3, which is 0.333 repeating. Therefore, since we had the same number on both sides, we know that this solution was true. Again, because there was a solution, this was a conditional equation. Okay, let's do another one. First, we want to get rid of the parentheses. So when we go through now and try to simplify each side, the left side gives us 7 minus 9z. There's nothing to do on that side. On the other side, though, we get 6. Then we've got a negative 8z minus 1 more z. So that would give us negative 9z. Next, we want to get the variable terms all on one side. So we've got a minus 9z. So to move that to the other side, we're going to go plus 9z plus 9z, and we would get 7 is equal to 6. Because the variables canceled out and the result is not true, 7 does not equal 6, then we would say that there is no solution. We can also write the little no solution symbol, and this is called a contradiction. Okay, what about one like this? First thing we want to do is clear out the parentheses. So we're going to multiply everything in the parentheses by the number out front. That would give us 1/2 x minus 1/2 times 3 would be 3 over 2 minus 2 over 3 times 2x, 4x over 3. And then a negative 2/3 and a negative 5 would give us a positive 10/3. Because we still have fractions, we want to find the LCD. Again, in this case, it's 12. So we're going to multiply everything, both sides, by 12. Well, when you distribute that 12, basically you're going to get 12 times each of the terms. Now we're going to go through and do our cross cancel. Notice this clears out the fraction, and that is a lot easier to deal with than what we had just a second ago. Now we're going to simplify each side. So on the left side we have 6x minus 16x, which would give us negative 10x. Then we've got the number terms. We've got a negative 18 plus 40. So negative 18 plus 40 would give us 22. Next we want to get the letter terms on one side, the number terms on the other. Well, we've got all the x's on the left, so we're going to bring the number terms to the right side, and we get negative 10x is equal to negative 17. Now to get just x by itself, we're going to divide both sides by negative 10, and we get x to be equal to 17 over 10, or if you put it in your calculator, you would get 1.7. Now, how would you check that? Okay, let's check this on our calculator by plugging in 1.7 for x. First thing, we would have 1/2, I'm going to put that in parentheses, times 1.7 minus 3, minus, then in parentheses, the fraction 2/3 times 2 times 1.7 minus 5. So for the left-hand side of the equation, we get 0.41666 repeating. Then on the right side, the fraction 5/12 also gives us 0.4166 repeating. Therefore, we know that our answer is x equals 1.7. Okay, now let's try one with decimals. To solve this equation, same thing. First thing we're going to do is multiply to get rid of parentheses. So we get 0.35t plus 6.5 minus 0.65 times t equals 5.5. Combine like terms would be negative 0.30t. We need the number terms to the other side. I'm going to go ahead and bring those over. Equals negative 1.0. To get just t by itself, we're going to divide both sides by negative 0.30, and that would give us t equals negative 1.0 divided by negative 0.3, 3.333. If you want to write that as a fraction, you can be on your calculator and go to Math. Option number 1 is fraction, and that will write that as a fraction 10 over 3. Now we want to learn how to solve these equations by graphing. To do so, you're going to let y1 equal the left side of the equation and y2 equal the right side of the equation. Once you do that, you're going to graph both equations, and then you're going to adjust the viewing window so that you can see all the points of intersection. Usually for these linear equations, they're only going to intersect in one place. Then you can use the calculator to calculate any points where they intersect. The x values of these intersection points corresponds to the solutions of the equation. Let's practice on our calculator. To do this, first you're going to come up here to the y equals button, which is the top left-hand corner, and we're going to let the left side of our equation be y1. So we can just type in 3 parentheses. Your x is up here. Second button, second row, second column, x minus 4. Then we can go down to y2. y2 is going to be the right side of your equation, negative 2x minus 6. When we graph these, I always start out and go zoom 6. That's always your standard Windows screen. And sometimes you're going to see the intersection here, which we do. So we know our solution is going to be this point right here. So to find that intersection point on our calculate, we're going to go second, calculate, which is trace, second trace. We want to calculate number 5 where they intersect. Notice it's asking us the intersection of what? The first curve. Well, the first curve is this 3 times x minus 4, so we're going to select enter. Now we're finding where it intersects with the second curve. Well, notice that the second curve is already on y2 equals negative 2x minus 6. So we press enter. Then it asks if we want to guess. Well, we don't because they only intersect in one spot, so we press enter again. The x value is our solution. So x is equal to 1.2. Let's do another one. This time we're going to go back to y1. y1 is 5x minus 4. y2 is 14. When we press graph, and I didn't change my window, notice there's only one line on there. Well, that's because y equals 14 is not in this negative 10 to 10 window. So typically what I'll do is I will go to zoom fit, which is zoom 0, and that goes out and finds a window that fits both equations. So if I press enter, it's going to resize the screen, and that shows both equations. So notice this is our point of intersection, so we're going to go second trace, which is calculate. Number 5 is where those lines intersect. Enter for the first curve, enter for the second curve, enter because we don't want to guess, and the solution would be x equals 3.6. Okay, let's do another one. This time it says round to the nearest hundredth. Y1 is 4 times x minus the square root, so we're going to go second square root of 2. Close the 2 for the square root and then the parentheses equals y2. Now notice on this one that the square root of 3 is times x. It's not the square root of 3x. So we're going to go the second square root of 3, close the 3, x minus 6. Press graph. Now remember we're zoomed way out, but that's okay. We see where they intersect. If we would have done zoom 6 for the standard viewing window, there's the first one, there's the second one. So we're going to go second trace, which is calculate, intersect, enter, 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 and we get a solution of negative 1.513. Because it says round to the nearest hundredths, our solution would be x equals negative 0.15. Okay, now we're ready to do some applications. In order to receive a B in a course, it is necessary to get an average of 80% correct on 2 one-hour exams of 100 points each, on 1 midterm exam of 200 points, and on 1 final exam of 500 points. If a student scores 92 and 86 on the one-hour exams, 146 on the midterm exam, what is the minimum score on the final exam that the person can get and still earn a B? Normally, to find the class average, you take the sum of all the test scores divided by the number of tests that you have, and that would give you the average. Well, in our case, because all of the scores are a little bit different, we need to go about it a little different. Total points, we've got 2 at 100, so that's 200 points for those, a midterm of 200 points, and a final exam of 500 points. So we have 900 points total. To get 80% correct, that would be 720 points. Well, so what we've got is we've got the first test score, which is 92, the second test score, which is 86, the third test score of 146, and then whatever we do on our final exam, and that has to give us 720 points. So when we add all of these up, we get 324 points, plus whatever we make on the final would have to give us 720 points. So to get to the 720 marks, we're going to go 720 minus 324. So that means we need 396 points out of 500 on the final exam in order to get a B for the course. Now for the next example, the sale price of a Cleveland State t-shirt is $20.80. This is 20% less than the regular price of the t-shirt. What is the original price of the t-shirt? Now, this is not your typical percent problem because you don't want to find 20% of the $20.80. What you've got is you've got the original price of the shirt minus the amount of the discount, and that equals the sale price of the shirt. Well, what is the original price? We don't know. We're going to call that X. The amount of the discount is 20%, but it's 20% of the original cost of the shirt. So we're going to call that 0.20 times X, and that is equal to the sale price, which is the $20.80. So now we're going to go through combined like terms. So the X minus 0.20X, that's like 1X minus 0.20X, which would give us 0.80X, is equal to $20.80. So to get this answer, we're going to divide both sides by 0.80, which would give us 26, which means that the original price of the shirt is $26. Now, you're going to have a homework question talking about low-calorie bread. Just remember, you've got the regular serving minus the discount for the low-fat or low-calorie, and then that will give you the light bread. So just keep that in mind when you get to that problem in your homework. Okay, the next type is a mixture type. And I found that the easiest way to do these mixture problems is to draw your mixture cups or your mixture buckets. This one says how many liters of a 20% alcohol solution must be added to 20 liters of an 80% solution to get a 40% solution. So the first thing you want to do is label your cups. So we've got a 20% alcohol solution that we're mixing with an 80% alcohol solution to get a 40% solution. Then the next question is, well, how much of each do we put in there? Well, it says how many liters of a 20%, so that's going to be X, must be added to 20 liters of an 80%, so that is our 20 liters. And then the 40%, how much is in there? Well, if we had X liters of this and 20 liters of that, then the amount in the final bucket would be X plus 20 liters. Then you're going to set up your equation. Well, 20% of X liters is found by doing 0.20X. 80% of 20 liters is found by getting 0.80 times 20 liters. And then the last one, 0.40 times X plus 20. It's always the percentage times the amount in each cup. So we would get 0.20x plus 16 equals 0.40x plus 8. So we get 16 equals 0.20x plus 8. Now we're going to subtract 8. So we get 8 equals 0.20x. To find x, we're going to divide both sides by 0.20. So x is equal to 40 liters. The next example is a ratio and proportion problem. A person 5 feet tall casts a shadow that is 4 feet long. How tall is a tree that casts a shadow of 18 feet? Notice we're measuring two things. We're measuring the height of the object and we're measuring the shadow on the ground. So when we set up our ratio, we've got our person and then we've got our tree. So our person is 5 foot tall and the shadow is 4 foot long. Then we've got a tree that we don't know how tall is and a shadow of 18 feet. Notice these are two similar triangles, and similar triangles are proportional, and we're trying to find how tall the tree is. So 5 is to 4 as x is to 18. This is the height of the person, the shadow of the person, the height of the tree, and the shadow of the tree. To solve a proportion, you cross multiply. 4 times x equals 5 times 18, which means 4 times x would be equal to 90. Divide both sides by 4. So 90 divided by 4. So on our calculator, 90 divided by 4 is 22.5, which means the height of the tree is 22.5 feet. Okay, last one. A rectangular Persian carpet has a perimeter of 244 inches. The length of the carpet is 26 inches more than the width. What are the dimensions of the carpet? This means find the length and find the width. Well, anytime there is a rectangle, I've always found it's best to go ahead and draw your rectangle. You've got the length of the rectangle and the width of the rectangle. You also know the perimeter. Well, remember, perimeter is the sum of all the sides, or the formula is 2 times the length plus 2 times the width. So let's go back and fill in our pieces of our rectangle. The length of the carpet is 26 inches more than the width, so let's let width be x so that the length could be 26 inches more than the width. So that would be x plus 26. That's the hard part. Now we're just ready to plug in. The perimeter is 244. That's equal to 2 times the length. Well, we just said that the length was x plus 26. The width we said was x, so that's going to be 2 times x. Well, when we set this up, we're going to get 2 times x is 2x. 2 times 26 is 52 plus 2x. Combining like terms, we get 4x plus 52. So we are going to subtract 52 from both sides. So we would get 192 is equal to 4x. Using our calculator, 192 divided by 4 is 48. So x is equal to 48. That means that the width of our rug is 48. The length is whatever the width was plus 26. So 48 plus 26 would give us 74. So the width is 48. The length is 74. How would you check it? Well, add up the length, the width, the length, and the width, and you should get 244 inches. Which, when we plug in the length of 74 and the width of 48, that does give us a perimeter of 244 inches. And you are now ready to do the homework for Module 4, Topic 4.1.